Assalamualaikum dan selamat sejahtera. Saya Usman bin Ideal Daha. Hari ini saya ingin membentangkan tentang iaitu subjek fluid mechanic dan topik Reynolds number. Jadi Reynolds number have 1, 2 and 3 dimensional. Term 1, 2 or 3 dimensional flow refers to the number of space coordinates required to subscribe the flow. It appears that any physical flow is generally 3-dimensional, but these are difficult to calculate and call for as much simplification as possible. This is achieved by ignoring change to flow in any of the directions, thus reducing the complexity. It may be possible to reduce a 3-dimensional problem to a 2-dimensional one, even and 1-dimensional one at times. Uniform flow and steady flow. Flow of fluid in which each particle moves along its lines of flow with constant speed, and in which the cross-section of each stream tube remains unchanged. Compare steady flow. Create an additional anchor point for your bow, just as a kisser button or a uniquely designed grip. A C-shaped cuff and bar connect the shooter forearm to the string stop on the bow. It comes in multiple color choice and in 2 models. Number 3 is closed and open system. The open systems that we know of are systems that allow interaction between the internal elements and the environment. An open system is defined as a system in exchange of matter with its environment, presenting import and export, building up and breaking down of its material components. Closed system is, on the other hand, are held to be isolated from the environment. Equilibrium, the thermodynamic, for example, is a field of study that applies to closed system. So, for example, for this topic calculation problem is, the question is, a liquid is following through a pipeline of 2 cm diameter. The dynamic viscosity of liquid is 8629 times 10, and the specific gravity of the liquid is 1.26 with velocity 30 cm per second. Calculate the Reynolds number and type of flow. Our solution is, we separately take out the point so we can easily make the solution. So we take out the D, which is the diameter, to cm, and we convert to meter, which is 0.02 meter. And for the velocity is 30 cm per second, and we convert it to meter per second, which is equal to 0.3 millisecond. So for the kinematic. So the kinematic is 8620 times by 10 Newton second per meter. We convert to kilogram per meter. And for the density, is 1.26 time by 1000 kilogram per meter. So we want to find the V, which is the velocity. So we take the dynamic viscosity and we divide to 12,600 and we got 6.4x times 10 meter per second. And for the what we call it, Reynolds numbers equal by velocity times by diameter divide by velocity. I mean kinematic viscosity. So equal 0.3 times by 0.02 divide by 6.84 times by 10 kuasa negative 4. And equal, the answer is 8.77. So it's under 2000. So the Reynolds number of the flow is 8.77. Therefore, the type of flow is laminar. So from our calculation problem just now, we got that the type of flow is laminar. That's all from me. I'm Osman. Thank you.